Yes. Finally a new video by Decodes.
Hello guys. So yeah, since it's been long that I've uploaded my latest video, this one, I was a little busy with my academics and everything. So yeah, but I won't let it go incomplete. So this regression part, today we are going to discuss about polynomial regression in this video. And I hope you are familiar with the concepts of regression and how it is different and what is classification and everything. Everything is available in my channel. So yeah, polynomial regression, as the name itself, you will understand that the graph that is going to be produced is going to be a polynomial. Of what degree is what we have to understand, what we have to apply it in our model. So yeah, the first of all, we'll understand the data set. That is, this data set is position salaries. That is what each person in which position gets what salary. So if he's a business analyst, his level is 1, he gets paid 45,000. The CEO, who is level 10, and he gets paid a certain amount, right? So I think 100,000 something. Okay, so the thing is, since you are all familiar with the concepts of what our basic data set is or data set should look like, and this is a very small data set, I'll explain to you guys that salary column, that is the last column, is our dependent variable, that is y, that we are going to predict. And the first two column may or may not be our independent columns. So why I said may or may not be is, if we are using a string value, we do not directly train it into a model. If our data set has a string value in it, we do not directly train it into a model. We first encode it using, there are various encoders like one hot encoder, ordinal encoder, and label encoder and everything. Okay, so first we encode it and then we train it into a model. So what does encoding means? Encoding means that we change the string values and give corresponding numerical values, it be binary, decimal, or anything. Okay, so here, since why do we don't have to do that is, this position already has its level in it. That is, each position is already given a numerical value, that is 1 to 10. Okay, so all we have to do is train it into the model and check it. That is, this level part has various numerical values. And if, let's say, if there is a guy between manager and country manager, that is 4 and 5, let's say 4.5%, how much will the 4.5% get? That is what we have to predict, that is his salary. So I hope you are now familiar with what this data set is. Okay, so let's go to the code. Okay, so this is yeah, we executed our header files, that is numpy array, matplotlib, and pandas. So now in this part, you can see there 1 to -1. That means we have to start including x from the first column, not the first column, that the column starts from the 0th part. So excluding that 0 part, we have to start from 1. In including 1, we have to go till the end. But when it says -1, that is, we have to exclude the last part. So here there are only 3 columns. We start from the second column, that is column number 1, and we exclude the last column. So that means that x contains only the middle column and y contains only -1, that is the last column. Okay, so that is how we have distributed x and y. So now we train. Okay, so I hope you are familiar with this concept. We have already discussed this in previous videos. I'll put up the link for it into description. You can check out my channel also. There is, I have explained a linear regression model. So the thing is, in linear regression model, we get a line that goes through each and every point, that is the best fit line. So first we train it here so that we can compare how it is different from polynomial and what is different in linear regression model. And we also train it for polynomial regression. So here, as you can see, the only difference is these two lines. So we called polynomial features from scikit-learn pre-processing library, and what we did is we set that polynomial features into degree is equal to 4. Hope you are all familiar with the mathematical concept of what a degree of an equation is. So that is what the degree here means too. So degree is set, and then we convert our, that is fit transform our data set, that is x value, that is the middle part, into x poly. Now we train it. We train it using the linear regression model only. So that is what you have to understand, that you don't have a polynomial regression class that you train in it. No, you have polynomial features to train on, and then you run it in a linear regression model. So yeah, and okay, so first we visualize this. So this is our best fit line. This is what we are visualizing is the linear regression part, the first part, that is this code is what we are visualizing here. So obviously this is a curved line, and this is what we are getting, this is wrong, right? So the next, if we visualize, we are getting yeah, let me go for a smoother curve. Yeah, so this is what we are getting when we train it with polynomial degree is equal to 4. So you can see that it is passing through most of the points, and this is what happens when you always you have to understand that you have to first plot your data set. So that gives you an upper hand on deciding what types of algorithm you can use, or what types of algorithm may or may not you can eliminate all those tuning parts and all. Okay, so yeah. So what if I use the earlier straight line model to predict my values for 6.5, a person with a level value of 6.5. Let's check our data set again. So my data set says that 6.5 value, that is somewhere between this, the man should get paid 1,50,000 to 2 lakh. Yeah, 2 lakhs. So between that is what his pay scale should be, but my linear regression model predicts that he should get 3,30,000 rupees. So obviously the company is at loss, right? So that is not the right model to be used. In this we are getting 1,58,000 or 1,60,000, which is fair enough. He's between 6 and 7. He's getting a value between 1,50,000 and 20,000. So that is how you predict using a polynomial regression. Hope you liked this video, and you understood the concept of polynomial regression and what are the few changes that has happened from the linear regression model. And we will next meet in our next video with maybe different algorithm. Hope you like this. Thank you.